Hello guys, let us look at Cramers Rule. You can be given two simultaneous equations as follows. You have A1 x plus B1 y, and you are told this is equivalent to a constant which I will call my D1. Then the second equation you are told is A2 x plus B2 y equals to a constant which I'll call it my D2. And you are told to find x and y. If these two are your simultaneous equation, Cramers Rule argues that for you to get x, first you derive the matrix from this equation. And we know that when you derive this matrix, we shall have a matrix like A1, A2, B1, B2. That way. So it argues that if you want to get the first value, the denominator becomes the matrix that is derived from these two independent variables. The numerator, I will pick the same denominator here, but this time replace, since you are looking for the first independent variables, replace with my D1 and D2. So I look for the determinant of D1, D2, then I pick the second column here, B1, B2. When I find the determinant of this divided by the determinant of this, automatically I'll get my x. If I want to get the second independent variable, which is y, I still do the same. I maintain the matrix derived from the independent variables, which is A1, A2, B1, B2. But the numerator this time, I will only replace the second column with my constants. So the first column remains the same, A1, A2. The second column becomes D1, D2. When I get the determinant of this numerator and the determinant of this divided by the determinant of this, automatically it will give me my y. If it is a 3 by 3 matrix, for instance, you can be given a 3 by 3 matrix like a 3 simultaneous equation, which we have A1 x plus B1 y plus C1, and I can use Z equals to D1. Then I'm told we also have A2 x plus B1 y plus this is B2 plus C2 Z equals to D2. Then I'm also given A3 x plus B3 y plus C3z equals to D3. So if you are told to solve for x, y, and z using Cramers Rule, this is what it argues that if you want to get the values of x, y, and z, you can first get the matrix. The matrix is A1, A2, A3, B1, B2, B3, then you have C1, C2, C3. This is my matrix. I can extract the matrix from this simultaneous equation. Then I have x, y, z, which equals to D1, D2, D3. So Cramers Rule argues that if I want to get the first independent variable, the value of x, I will have a numerator here that I need to find the determinant, and I will have a denominator that I need to find the determinant. The denominator is the initial matrix. So I have A1, A2, A3, B1, B2, B3, C1, C2, C3. The numerator, I'll pick this, but since I'm looking for the very first independent variable, I replace the first column with my constants. So the first column of this matrix becomes D1, D2, D3, then I maintain the other two columns, B1, B2, B3, C1, C2, C3. In other words, if I get the determinant of this matrix divided by the determinant of this matrix, I will comfortably get the value of x. To get the value of y, we have already gotten the value of x, so we replaced the first column with D1, D2, D, and 3. So these are the constant. You replace the first column. Here you find the determinant of this matrix and the determinant of this other matrix. If you want to get the second independent variable, which is now y, if you want to get the second independent variable, which is y will be given as follows. We maintain the denominators. We maintain the denominator here. So we have the denominator, the numerator, we shall replace, since this is a second independent variable, we replace the second row. So my second row is what we need to replace. So this one we maintain A2, A3. My second row now becomes D1, D2, D3, while my third row still remains to be C1, C2, C3. This is the value for y. If you want to get the value for z, you maintain the numerator again. The numerator still remains. So the value for z will be given as follows. The denominator still maintains. So since it is the third independent variable, we replace the third row. So my first row is A1, A2, A3, B1, B2, B3. The third column becomes D1, D2, D3. If you find the determinant of this matrix and you divide by the determinant of this matrix, you will get the value of z. You will get the value of z. Let's learn about application of the Cramers rule. To apply Cramers rule, you can be given such an equation: 3x plus 2y equals to 3, 2x plus 3y equals to 7. You are told solve for x and y. So this is the solution using Cramers rule. We have been told first we extract the matrix from here. We have 3, 2, 2, 3. Then I say this equals to x, y, xy equals to 3 and 7. I need to solve for x. To solve for x, the denominator becomes this matrix. We maintain this matrix as the denominator. The numerator, we use the same matrix, but replace the first column, because we are looking for the first independent variable, with these constants. So I have 3 and I have 7. I have 2, I have 3. All I need to do is to find the determinant of this and divide by the determinant of this matrix. Then I can have my value of x. To find the determinant of this, you take 3, multiply by 3, which is actually 9. So here I have 3 multiplied by 3 minus 2 multiplied by 7. The denominator becomes 3 multiplied by 3, that is 3 multiplied by 3 minus 2 multiplied by 2. So if you solve this, here we have 9 minus 14, that is minus 5. We have 9 minus 14, that is minus 5, divided by 9 minus 4, which is 5. This means my x is negative. My x is negative 1. My x is negative 1. To get the value for y, to get the value for y. I still do the same. My denominator still remains. My denominator is 3, 2, 2, 3. I need to look for the determinant. My numerator, this time I use the same matrix, but since I'm looking for the second independent variable, the value of the second independent variable, I interchange the second column here with these constants. So I maintain my first column as 3 and 2. The second column I interchange to have 3 and 7. And I find the determinant of this matrix and the determinant divided by the determinant of this matrix, then I'll get my value of y. So the determinant here, we have 3 multiplied by 7, which gives me 21, minus 2 multiplied by 3, 2 multiplied by 3, which is 6, divided by 3 multiplied by 3, that is 9, 2 multiplied by 4, sorry, 2 multiplied by 2, that is 4. So here we have 15 divided by 5. That means you divide this by 5, we have 3. My y is equals to 3. We can try to prove if these answers are right by substituting these answers in one of the equations. So here I can have 3, I have known my x is negative 1, then I have plus 2 multiplied by 3. This you get negative 3 plus 6. If you add the 2, you get 3. And this 3 is actually the same we have here. That means the Cramers rule is accurate when you are computing the value of two unknowns in two simultaneous equations. If you are given a simultaneous equation of three simultaneous equations with 3 unknowns, and you are told solve for x, y, and z using Cramers rule, this is how you solve this. This is how you solve this. First, we extract the matrix from the equations. So we shall have 1 extracted from here. Then we shall have 2 extracted from this. We shall have 3. Then we shall have 3. Here we have 1. We have minus 3. Here we have negative 3. We have 4. And we have 7. That is our matrix. So the 3 unknowns is x, y, and z. We say this is equals to negative 5, 4, negative 7. Negative 5, 4, and negative 7. So we are taught to solve for x, y, and z using the Cramers rule. So x will be given as follows. X will be given as follows. X will be given as follows. We have two matrices that we need to find the numerator and the denominator. The denominator is this matrix. We find the determinant of this matrix. So we have 1, 3, negative 3, 2, 1, 4, 3, negative 3, 7. The numerator, we maintain the same matrix, but since you are finding the first unknown, we replace the first column with this. So the first column of this numerator becomes negative 5. We have 4, we have negative 7. Then we have 2, 1, 4. We have 3, negative 3, and we have 7. To get the value of x, we are supposed to get the determinant of this numerator and the determinant of this denominator. If you work out the determinant of this, you will get negative 40. The determinant of this, if you work it out, you will get 40. That means our x will be equivalent to negative 1. We can solve, this is the determinant, and here we also look for the determinant. So we can also look for y. For y, we maintain the same denominator. We maintain the same denominator, 1. We maintain the same denominator, 1, 3, negative 3, 2, 1, 4, 3, negative 3, and 7. But since y is the second unknown, this time we replace the second column with these constants. So we have 1, 3, negative 3. We need to find that determinant. The second column now becomes 5, 4, negative 7. The third column becomes 3, negative 3, and 7. If you work out the determinant of this matrix, you will get 40. And the determinant of this matrix, you get 40. That means your y will be equals to 1. You can also find for z. Here we need the two matrices, which we need to find the determinant. So we maintain the same denominator, 1, 3, negative 1, 2, 1, 4, 3, negative 3, and 7. Since z is the third unknown, we replace the third column with this. So the third column of this matrix becomes negative 5, 4, negative 7. The first two columns remain the same, 1, 3, negative 1. We have 2, 1, and 4. So if you find the determinant of this matrix, you'll get negative 80. And if you find the determinant of this matrix, which we have already found out, we will get 40. This means your z is negative 2. That's how you solve three simultaneous equations with three unknowns using the Cramers rule. You can also be given such simultaneous equations with three unknowns, x, y, and z, and you are told to solve for x and y, and z. To solve for this, first we need to extract the matrix from these simultaneous equations, and we extract as follows. We have a negative 2 here, negative 2. We have 2, we have 2. This is for x, column for x. We have now column for y's. Column for y's, we have negative 1. We have negative 3. Since the third equation doesn't have a y, we put a 0. Then we have a column for z's. For z's, we have a negative 3. Here we have 1. Then we have a negative 3. That is your matrix. The first column was x, second column was y, the third column was z. And all this should be equal to this. The first equation should be equal to 13. The first equation should be equal to 3. The second equation should be equal to 13. The third equation should be equal to 11. If you are to solve for x, y, and z, we solve for x and y and z as follows. We need to get x. So here, using Cramers rule, we maintain this. As our denominator. We need to get the determinant of that. This is 0. That is 0. Then the numerator, the matrix for the numerator, since this is our first unknown, we replace this to be the first column. 3, negative 13, and negative 11. The other two columns still remain the same. So here we have a negative 1, negative 3, 0. We have negative 3, 1, and negative 3. If you find the determinant of the numerator, you'll find it's 176. If you find this determinant, if you find the determinant of this denominator, you will get 44. If you solve this, you realize 176 divide by negative 44, you'll get negative 4. You'll get negative 4. That means your x will be equals to negative 4. To get the values of y, we maintain the same. To get the values of y, we maintain the same denominator, negative 2, 2, 2, negative 1, negative 3, 0, negative 3, 1, negative 3. The denominator is the same, only that since this is the second unknown, we use this as our second column. So we maintain the first column as negative 2, 2, and 2. The second column becomes 3, negative 13, negative 11. The third column remains the same, negative 3, 1, negative 3. So you find the determinant of this matrix and determinant of this matrix. If you work out the determinants, here, you will get negative 88. The determinant of this, you will get negative 44. You simplify this, you get 2. So our y is equals to 2. Our y is equal to 2. If you want to solve for z, you maintain the same denominator, negative 2. We have 2, 2. Then you have negative 1, negative 3, 0. Then you have negative 3, 1, negative 3. The numerator, we interchange, since we are looking for the third unknown, we interchange the third column with this. So the first two columns remain the same. The first two columns remain the same. The third column now becomes 3, negative 13, negative 11. If you find the determinant of this matrix divided by the determinant of this matrix, this is what you shall get. You shall get negative 44. This also you shall get negative 44. You simplify this, you find z is equivalent to 1. So you have your values for the three unknowns. X is negative 4, y is 2, and z is 1. Just to understand how to get the determinant, you can refer to our previous video on the determinants of a 3 by 3 matrix. Thank you.